Financial Modeling, Topic 8, Consumption Smoothing Personal Financial Planning Simulation Model by Lou Gaddis. If you're looking for references, I highly recommend Financial Modeling 4th edition by Simon Benenga. Chapters 1 will get you started on basic financial calculations. Chapter 8 will talk about how to calculate portfolio standard deviation and return. Then you'll have some chapters on generating random numbers, Monte Carlo estimation, and simulating stock prices. We'll talk about matrix algebra, which we'll use in this model in chapter 32. And then the remaining chapters will talk about VBA programming, user-defined functions, and subroutines or macros that are used in this program. Also, if you're looking, we're going to use the at-risk software for this model. And you can go to Palisades for discussion of at-risk. And lastly, if you want to use this model, you can go to my Google homepage. So go to Google Sites, Lou Gaddis, go to the Documents and Files section, and then you will find this file here. It's currently called AdvFinMod Topic 8 Start and End File FinPlan, and you can see the reference there. Or you can just Google Lou Gaddis Google homepage. So in this topic, we're going to understand key data needed for a personal financial planning model. In topic 2, we'll talk about consumption smoothing as a personal financial objective. In topic 3, we'll show a static personal financial model. By static, I mean a single point estimate, a deterministic value that has no randomness associated with it. Topic 4, we'll run a simulation using a macro. And topic 5, we'll run a simulation running at-risk software. So, section 1, let's talk about the key inputs needed for a personal financial plan. The first are, I'll call capital market assumptions. And what we're talking about are expected returns of assets, correlations, covariances, and volatilities or standard deviations. We also have to define what asset classes the client or investor is going to put their money in. I'm going to do 4 basic asset classes: U.S. equities, foreign equities, bonds, and money market. Money market are sometimes called just cash. Now, first of all, I'm going to do this model using real dollars and real returns. So for the U.S. stock market, I'm going to assume an expected return of 5.25. If I assume an inflation of about 2%, which I do later, that means it's more like 7.25 nominal return of the stock market. And for foreign stocks, I'll assume 5.83. Now, where I got these two numbers is through the global CAPM model, and that'll be shown in when I go switch to the spreadsheet. Now for money market, I'm just going to assume money market has the same return as inflation, therefore it's a 0 real return, and I'm going to assume bonds have 1% above money market. So what you can see is I'm assuming a market risk premium of about 4.25, the difference between stock market, the US stock market, and the bond market. So that's where I got the CAPM. Notice if you go to a spreadsheet, we'll go to it now, I have links to this data. So you can see there's the real return of the stock market. It's a link to this return data page, which then shows you it's actually calculating the beta between the US stock market and a global stock market and adding a market risk premium of about 4% to it. However, if you look in the spreadsheet, you'll notice I add 50 basis points to it. 0.5%. And that's because I just felt it looked like it was too low when I looked at the number. And that's always a role for judgment in financial modeling. And the same for the global CAPM for foreign stock market. I put a manual adjustment of 50 basis points because it just seemed too low. And then for money market, I just made the assumption of a 0 real return. And for bond markets, I made an assumption of 1% above money market. Or another way of thinking about it is a 4.25% market risk premium between US bond markets and US stock markets. As far as the correlations go, you can see they're linked back to this page here. And you'll notice I have 10 years of return data for ETFs that track the major indices. And I'm just using that 10-year correlation. So these are simply historical correlations. I also use historical standard deviations over that 10-year period with some manual adjustments because during this period was a big stock market crash, and therefore I thought that the volatilities I was getting from that 10-year period seemed too high, so I reduced them. So you'll notice that I'm taking 2% off stock and bond, US stock and foreign stock volatilities, because I thought that, say, 1954 was going to be too high for my forecast for long-term stock market returns, knowing what the very long-term average is. And then I just calculated covariance matrix. The covariance matrix takes into account the correlations and the volatilities I've estimated. So these are the basic capital market assumptions: the expected returns, volatilities, correlations, and covariances of my 4 asset classes. Some client inputs, some basic biographical data. I'm going to assume my client, or the person you're doing this financial plan for, is 21 years old, retires at the age of 65. Their current income is $55,000 per year. Their income will grow at 3% a year. Inflation will be 2% a year, so it looks like they're going to grow their salary about exactly 1% above inflation. They're going to say they have no money saved today. They're going to save 15% of their income for retirement, and the company has a 0 match, so there's no company match by the employer. And we'll also assume that this person is going to live to 85 years old with a standard deviation of 7 years. And by the way, if you're doing this financial plan and you're assuming this is going to be a couple, I would use 91, because some data I have received is if a couple are alive at the age of 65 and retire, they're expected to live to the age of 91. So that's a conditional life expectancy. If you're a single person, like we all are, and we live to the age of 65, we're expected to live till 85 with a standard deviation of 7. If there's a couple, both living at age 65, the last remaining spouse or partner will expected to live to 91 with a standard deviation of 5. So bottom line, if you're doing this for one person, I'd recommend 85 and 7. If you're doing this for 2 people, I'd recommend 91 and 5. So I just talked about the key inputs needed for this personal financial planning model. In the next topic, I'll talk about consumption smoothing.